In this exercise, I'm going to show you how to draw using radians. And it takes a little bit of getting used to, but it's not that hard. I don't want you to look at it and say, oh no, I don't want to do this. This involves math. But I will tell you that having a couple of basic math tools from your old geometry days will help you tremendously. So you'll notice that in our supply list for this class, I recommended that you have graph paper, a compass, and a protractor. And I find that I've done this car using a compass and I'm using a protractor to figure out what the heck I'm doing. So this is sort of a VW bug-ish. It's inspired by a VW bug. And I need to figure out where to start. Well, I'm going to start by drawing this first line of the body here. And so I have that where I'm working out here, and you can see I'm working with ink to show you what I've done. And this is pseudocode. It's just, a pseudocode is like an outline for a paper. It's just the steps I need to do. So the first step always is set size. So the size of my screen is going to be 500 by 350. 500 wide, 350 tall. Now you'll notice I have put extra lines in here, and I sort of cut off the ones at the top. So you can see this is 50, 100, 150. That really helps me figure out where my starting point is. Since I was using a compass, I know that the starting part of my circle right here, A, is at 250 across and 280 down for Y. So that's my XY points, 250 by 280. That should be pretty comfortable for you. Since I'm only going to be working in circles here, the width and height will be the same. The width of my circle was 360, and since it's a circle, not just an ellipse, it's 360 by 360. How did I figure that out? I took it from the widest part here and I counted. I actually counted half and then multiplied by 2. Now the next part, and in my scribbles here make it a little hard to see, but it's clear up here. It's 200 with 325. Because this, now I'm going to show you the tool that I'm using here, my protractor. And I was trying to figure this out, and the first time that I did it, I programmed it upside down, because you can either read from 0 or 180 this way, and the first line here is at 160 degrees or 20 degrees, depending on which way you're reading it. Now, this is where it gets a little bit confusing. Radians start going in this direction. They go clockwise, and I'm used to going sort of counterclockwise, or this being different. So you have to be aware that this is 0, this is 90, this is 180, this is 270. So how do you use this with your protractor? Well, it's really simple. 180 is right here. Just add whatever the number is on top here to 180, and it'll give you the correct results. So my first arc starts at 20 and ends at 145. So 20 plus 180 is 200, and 145 plus 80 is 325. So that's how we figure out our formula. We have our center point, X and Y. We have the width and height of the circle, and then we have the radians that we start at and the radians that we finish at. And if I program that, you'll see the first step is setting my size, and you should be using your notes telling yourself what part of the car you're working on. And if you want to, it's not a bad idea to give yourself, the first time you see a formula, not every time, but the first time you see a formula, letting yourself know that it's your X coordinate, your Y coordinate, your width, your height, starting of curve, end of curve. And I won't do that every time I type in a formula, but the first time I type one in, I usually do that to help myself. And this is about how I want you documenting your code. And then if I did this right, this should look pretty close here. And you can see I have the start of my bug. I'm going to go ahead and stop the video now, and I'm going to go back and I'm going to plan the windows of the bug. And you're going to see me working on each section, the windows, the hood, the left tire area, the right tire area. And I'll come back after each and show you how I figured each of those out and then add them to the programming code.